Hello, everyone. Thank you for coming to my talk. I feel like a stranger in this conference because this talk is not going to be about some cool C++ new feature, but it's more related to DevOps things, to continuous integration, things like that, package management, which are topics that I think are not so common in C++ conferences. So this is Javier García Sogo. I come from Spain. I'm working there in a package manager. And I want to introduce you the problem we have in C++ with ABI compatibility. I'm sure that if you are here instead of in the talk of Rainer Grimm, you are aware that ABI compatibility is more or less a problem, is something we have to deal with. C++ is a language in which we are compiling native applications. So it's not a problem of the language. ABI compatibility is a problem of software development. So the objective in this talk will be to give you some insight about this issue and also how can we deal with it. Before entering the problem, let me introduce just the topic with a couple of definitions. We are talking about binary interface, not application programming interface, the API, because the API is more related to the source code. So API, according to the dictionary, it's the set of functions and procedures allowing the creation of applications that access the features or data of an operating system, application, or other system. I like to look at API like a contract. So in this contract, some part of the contract will be ensured by the language itself or by the compiler, and the other part we have to rely on the documentation. For example, here is a screenshot of CPP reference. I'm sure all of you know this web page, and probably you enter it to check some contracts of the API. And here we can find that the API, the main parts of this contract. We have the name of the function, std apply. We have the signature. Okay, this function takes two arguments. The first one is a callable object, and the second one is a tuple. We have where to find this function. We know we have to include the header tuple. And as I told you before, there is a part that the compiler or the language cannot check, which is what this function does. So we have to rely on the documentation. It says that it will invoke the object f with the tuple of arguments. And this is the API. But the ABI, the application binary interface, from the Wikipedia, is the interface between two binary program modules. Please realize that we are talking here about modules in a generic sense. It's not the C++20 feature. And the ABI defines how data structure or computational routines are accessed in machine code. So it's like in runtime, how several modules of our application interchange data, or what do we have to do to call a function inside another library. This is something that it's not a standard in C++, and I think it won't ever be. Why? First of all, the C++ standard takes care of the language, not of the assembly. So it's not a problem for them. Also, there are two reasons that I think worth mentioning that are not having a standard allow the compilers to implement the most performant machine code for every target platform. And also, as several compilers have different binary interfaces, we cannot choose one of them over the other because it will be a competitive advantage for the chosen one. The ABI can be affected by several or many different things. I like to categorize those in two groups. One of the groups depends on the developer. So on us, we can affect the ABI of course, we know that last term the ABI is generated from our source code, so we can change it. But the other great group is related with the infrastructure. So things more which are under the umbrella of the project engineer, the build engineer, the DevOps guy, the continuous integration system, or even the sysadmin. There are things like the calling convention, which are the order of the arguments, how to pass them to the functions, if they are passed in the stack or in register, how to free that memory afterwards. Things like exception handling, you know, there are several ways to handle the exception. When we raise one from our code, the system needs to know how to look for a function that handles that error, how to delegate the work in that function, how to delete the intermediate objects, and all those things. Also, the name manglings depend on the compiler. Different compilers generate different manglet names. That is, the name manglings refer to the mapping between the names we use in the source code and the names used by the linker to identify the classes, structures, or functions. And also, of course, by the C++ runtime, which is the library the operating system provides us to access different utilities and functionalities from the operating system itself. The other category of things, as I told you, it's more related with the developer, which is the source code. And okay, the developer cannot choose which is the binary representation of the types, but he can choose which types to use. He can be aware of different cache layouts, cache alignment problems, and also you know that in C++ we have inheritance, namespaces, overloading, a lot of possibilities that can affect our ABI. So if the ABI can change, it makes sense to talk about compatibility or about ABI unstable one. So we say that binary compatibility is a property of a library, so that if we have an application that has been linked with an old version of the library, we change the library with a new version of it, and the application still runs and still works by some definition of work. Okay, it doesn't crash without the need of compiling it or linking it again. We don't have to mix it with source compatibility, which is just the property of some libraries. You know, when you plug a new version, you have to compile against it to link it again, but you don't need to modify your code in order to work. So before continuing, why I am interested in all of this? I'm working as a software engineer in Jeffrock. You know, Jeffrock is an international startup based in the United States and Israel with offices in India, Japan, France, and also in Spain, which is the place where I am working right now. Jeffrock, maybe you know this company because it's the one who develops Artifactory, which is, in a couple of words, a binary database. Okay, not so simple. It's a full ecosystem of application and utilities around Artifactory that take care of all the life cycle of your binaries. Within Jeffrock, I'm working in the community and partnership division, where we are trying to develop useful application for the community. We created this year the Go Center, which is a central repository for the Go language, and we also developed Conan, which is a C++ package manager. So I was a C++ developer like you all for more than 10 years, and it was my life as a C++ developer. You know, this is a hard language, But we also are in love with this language. We keep pushing the wheel of pain. But for sure, you and me, we have, instead of reusing some library, we have just copied the sources, passed it in our project, and compiled it. Okay, sometimes it's much easier to do that than to depend on a third party. And some years ago, I started to work with other languages, and I found that all of them has package manager, and that tool allow people to create prototypes in a very quick way. So you can just start your program, you find a useful library, like in Python, you make pipe install whatever, you import a file, and from that very early moment, you can start using those functions, and you can build prototypes really quickly. And I wanted something like that for C++. I looked in internet and found that a couple of guys in Madrid were developing a package manager. At that time, they were in another startup called Bcode, but they changed the project with a new, different approach, and they started to call it Conan. Conan is a free open source software with MIT license, which means that basically you can do with it whatever you want. And the thing that I appreciate more about Conan is that you can use it in your project without the need of modifying what you are already using to compile it. So it's not intrusive. Okay, probably you have to touch some lines, but generally it gets into your project without modifying it too much. Also, you can use it for every build system. Just to share with you some numbers and where you can find us, we are in GitHub. You can open issues there. We will love to hear feedback from our users. You can also find us in CPP-Lang, in the Slack, in the Conan channel, and also in Twitter. Right now, we are 6 people working in Conan. 4 of us are in Madrid, and we have a guy in Brazil and another one here in Russia, which is Konstantin, who is part of the Core Hard community in Tomsk, and is around the conference too. And by the way, we are hiring, just in case you want to move to Madrid, a sunny place, and enjoy our weather, come. And coming, also, I take care of the C++ user group in Madrid, so you are invited to come to talk there. This is a talk we have in January. We have Björn Stroustrup himself, so it was an amazing event. But coming back to our topic, this is a famous painting. I don't know if you know, by Pablo Picasso. I don't know if you know what it is related to. Okay, this is a runtime error. You know, the manager is looking for a responsible, the developer is hiding somewhere, the DevOps guy and the CI are looking at another place, the customers are shouting, and so on. Okay, not really. You know, this is after the Spanish Civil War, before the Great Patriot War or the Second World War, that a city in the north of Spain was bombed, and this is what motivated Picasso to paint this, maybe the most famous picture of the 20th century, for sure in Spain, and I think it's well known all over the world. So thinking about this, and up to now, I wouldn't say that ABI compatibility is not a major problem. It's a big problem, it's hard. There are too many things that can affect ABI. So let's try if I'm able to change your mind. Okay, first of all, think about C++ development. There are two extremes. No? On one side, you have the application, the monolithic one. You have all your sources in your repository. You are compiling it again and again, always from sources. You don't have plugins, so you have a really boring application, I think. Maybe you don't have ABI compatibility problems. And in the other side, we are sometimes library authors, and we want to sell our libraries, we want to sell our binaries, and then we have to take care of ABI compatibility, because otherwise we will go back to the previous painting and the chaos when we break our customers. You might think that, okay, I'm writing a header only, why does it's not a problem for me? I think, yes, it is. If you want your header only to be used in my library, I want you to take care about ABI compatibility, just in case I need to expose one of your types or your functions or whatever you are providing. Because my ABI will get contaminated by your types. So if you change them too often, I will break my ABI and I won't like your library. So I was working for a couple of years in the previous example with a monolithic application, and I can tell you that it's so boring. Boring in the sense that it's not a funny application, but also in the sense that you are compiling again and again the same sources, and it doesn't make sense. You are losing too much time. So let's go on. Let's see different scenarios where our ABI can break. First of all, we have a challenger here, which is the runtime. As I told before, you could think that a very simple application, a monolithic one, cannot have binary issues. This is a C application. Okay, I have to look for it in internet. I can't write this code anymore. And what it does is it is listing the files in the working directory. I compile it as a C application, run it, and okay, I get the list of files. Do you think this can ever have an ABI problem? Can it fail in some use case? Yes, I think that that hands up, it's because you think it can fail. Of course, if it's here, it's because it's going to fail. When? When we run it with a different libc runtime. So there are many different implementations of the C library. And the problem is that the C runtime is provided by the operating system or by the running distro. So if we link with one of them and that one is not compatible with the one in the distribution, it is going to break. Why are there different implementations? Okay, maybe some of them are targeting what they consider a bug, or maybe just for performance issues, or because they think they can build a smaller library. And when we run our application, we sell our application and it is run in a different environment, we can get different errors. I have 3 of them in this slide. The first one, I linked my application with the muscle C library. And when I run it and in the distribution, there is no muscle libc, I get that error. But the second one, I don't even know what's happening, but it fails. And in the third one, it's just a problem of the glibc version. glibc is probably the most common or spread library, C library out there. So it stands for the GNU C library. It's supposed to be backwards compatible, although from time to time they remove some functions. Okay, I assume those are deprecated and no one is using them, but okay, it's not the definition of backwards compatible. And having a C library which is backward compatible, one strategy you can use to build your binaries, your application, is link with the oldest C library you can. Like I'm putting here like CentOS 6, which is really old, and then it will run with new C runtimes. Nevertheless, take into account that if there are new versions, it's because they are solving bugs, they are introducing new features, so you won't be able to use them if you link and compile with an old one. And even if it works, not just because the bugs you are not getting, you can have another different problems. I come across a email change from TripAdvisor, and they realize, okay, they use a database, a Postgre database, and they deploy their application in different operating systems. They do this, they compile with an old C library and run with new ones. And it happens that the collation ordering for Unicode is not guaranteed between different versions. So they get different results from different machines. And it was a really long email change talking about this and who to blame. Remember? Manager running after looking for someone to blame. So beware, the runtime. Another challenger are the tooling ecosystem. Okay, this is C++, we need for sure a compiler. Compilers evolve, and they, from time to time, we have a new version with new functionalities and the ability to compile new C++ features. In this evolution of the compilers, they have to deal with changes in the ABI. Sometimes they introduce bugs, which was what happens in the 4.7 release. Always, of course, they roll back that change. But there was another change that was very famous or very important when C++11, when they implemented C++11, they had to deal with a new ABI. Because, as you know, there was the requirement of a different, the STD string has a different size, and more or less we can say that the STD string is everywhere in the ABI. So they use a new feature of C++11 and also created this macro so you can choose which version of the library to link. How it works. So it happens in the release number 5. Well, they did what we call dual ABI. In a previous breaking change of the ABI around the release number 3, they just changed the name of the show name, and that's an option. But for this breaking change, what they did was, okay, we are going to provide the two ABIs in the C++ runtime, and you as developer, when you link with the C++ library, you can choose which ABI to use. So they introduced that macro in order you can choose it. Before release number 5, you have that signature for the function. Okay, there is no C++11 anywhere. But after 5, you can choose between the new and the old one. How can you do it? If you assign the value 1 to that macro, you get the new ABI. You can see there that there is a C++11 before the basic string name. And if you use the value O, you can get the old ABI. So with these new compilers, you can link with an old version and run in a distribution that provides you an old C++ runtime. But this is not so easy sometimes. Here, there is an example. I'm trying to link with the new ABI. So I'm trying to force it with the value 1 in that macro. I'm running in an old Ubuntu distribution, 14, and I'm using a new compiler. So I could expect to be linking with a new ABI. But what happens? Even if I use the macro with the value 1, I get the old ABI. Why? they decided to, okay, as Ubuntu 14 has only the C++ runtime, the old one, they decided in order to keep compatibility that the compiler should generate always binaries that will be able to run in that distribution. And this is something we face in Conan when we were generating binaries with Travis, because Travis was using an old Ubuntu and people just downloaded new compilers and they think they were generating binaries for the new ABI, and it was a couple of months we didn't know what was happening there. It also happens in Microsoft, of course. Microsoft, the Visual Studio compiler, I think it's a really, really great tool. Just released this month, the 2019. You know that the important thing for Visual Studio is not the release year thing, but the tool set which is running under the hood. 2019 comes with the toolset 14.2. And they claim it to be binary compatible with the two previous versions, which corresponds to 2015 and 2017. So here I have some use cases for you. The first one, I'm trying to link a library which is compiled with an old version with a module, another library, an application with a new version. Okay, it's not binary compatible, it's not going to work. The second one, of course, is the same toolset version, so it will work. And the next two ones is the same use case, but in one of them, the library is with the old compiler, and in the other one, it is the application, the one who is linking with the old one. According to that statement, both of them should work. Okay? They are binary compatible. I don't know, maybe I'm generating a library. I want to use new cool C++ features. I need to use the new compiler of Microsoft, and I want to deploy this new library to my customers. But they are not in the last Visual Studio. Is it going to work? If you keep reading Microsoft documentation, it says that, okay, it works if you link with the last version. So the third use case is going to work, and the last one, I have to say that I did little trials, and it works always for me. But maybe they don't want to state that just in case there is a break in the ABI. So far, so good. We think that our ABI can get compromised by the operating system, architecture, distribution. Those are providing us with the C++ runtime, many things. And also, of course, with our tools. But there are more things, more scenarios I want to show you. Sources. OK, let's have a very little bit of C++ here, just to show simple examples, OK? Here I have a library with an application, really easy one, just a couple of functions. One of them is implemented in the CPP file. The other one is in the headers file. I compile the library dynamically, and then compile the application linking to that library. My application is just calling the two functions. I get the results as I'm expected to. But it's supposed to get. Okay, in the first one, just the number 1, and in the second one, the number 2. What can happen during the lifetime of this library? Maybe, and this is the reason why we use dynamic libraries, we can change the behavior by changing the implementation. And we compile again the library, just generate the library, overwrite the previous version, and it works. We get the new behavior. Everything's fine. This is software development. This works. Another thing we can do is to change the name of one of those functions. Okay, in fact, what I'm doing is deleting one function and creating a new one. And I compile the library, run the application, and what happens? Nothing. Because that code is embedded in the consumer one. Okay. And that is an interesting new use case for inlines. When you have inline functions in a class and those inlines are calling private functions, we all know that private functions are not part of the ABI unless they are called from an inline function. So in that case, those private functions will become part of your ABI. If I do the same as the previous use case with the library that is implemented with the function that is implemented in the library, I get the typical runtime error saying that this library does not provide that symbol. This is also expected, and it's fine. This is what we want to happen. Another use case. I have some data structure in my library and a couple of functions. It's very similar to the previous, not to the previous, to the inline we were talking about before. Here, what I'm going to do, sorry, there is something wrong in the slide. In the second function, with the one which is called sum inline, there should be no C member in the struct. But okay, it's so easy. I think you can follow what is the intention of the implementation. And here, what I want to do is just I'm adding a new member to the structure and calling the function. So I compile again the library, execute my application, and call the functions. And what happens in the first use case, when I'm calling to the function that is implemented in the library, I get undefined behavior because the C member is not initialized, and it's reading memory and some weird number, and it's returning me something with no sense. And in the second use case, as the code was embedded in the consumer, nothing happens. And just a final example, which is the one which scares me most, is this one where I have std stream member, and I'm implementing some behavior in the consumer. No, it's tricky, of course. It's just an example. But here, I'm creating an object, and then, depending on the number of arguments, I'm using that object or just greeting with the argument I give to the application. In the first case, of course, I'm greeting Manuel, hello Manuel, and in the second one, I'm executing the application with an argument, and I'm greeting that argument, hello Javier. If I remove this member, then, and this is why it scares me, I'm changing my ABI, but it's only broken. It's only broken for one of the branches of the if statements. And I don't like it, because now I'm developing a lot in Python, and you know that in Python you have to cover it all with unit tests just to check that everything works for everything you can imagine. And this is like the same in C++. So it's probably, we can say that this program right now is undefined behavior, but only for some use cases. We can deploy that, and who is executing that use case? For sure, a key customer we are selling our library to. And the fourth challenger in this battle is the environment itself. For those of you who work in a big company, I'm sure you have gone through these stages. So usually you deploy your application, and this is like an schema of how it works. You have an operating system layer with the runtime of the C and C++. Over it, you use some third parties. You are buying to your vendors. You build your business logic in some libraries. and then you have application using all those libraries. At some point in time, you need another application, and it uses another third party. Okay, so far so good. But it will happen for sure that, hey, now we have that third party, let's use it. And eventually, I will need a new version of that third party. And in that version won't be ABI compatible with the previous one. So I have to do something like this if it can work. And things get worse, okay, until you get the picture. You get the runtime errors. And then you start to think about a solution. What can I do? Easy. Just make each application isolated. Deploy the application with all its dependencies in a different folder, or nowadays we have to say in a different Docker container. So, and I think that this is the reason of the great success of Docker. But now you have new problems. Your third parties and also your company libraries, you have many of them, and all are called the same. But you have to identify all of them. You have to know which one is the one you are running in its use case. And that's a problem too, because you will have myriads of libraries. And also, if you find a bug in the code, you have to apply it to every binary that could be affected. And that's a problem, not only identifying which one, but after applying it, you have to be sure that you are going to update and be ABI compatible with the library you are updating. That's a different problem, but okay, it's not hard, it's just not complex, it's a problem of how you handle it. And this is what we have so far. So we have our developer or our DevOps girl who has deployed a new version. Customers start to download it and to use it. And OK, she's relaxing. Nothing wrong is going to happen. But, this painting is by Salvador Dalí. The translation of the title, you see, it's a really long one. It's like the dream motivated by a bee flying around a fruit just a moment before waking up. And this is what happens when you are so relaxed until you get the runtime error. So as I said before, I think that the ABI compatibility is no longer a major problem. It's just a problem of how you deal with it. We saw that if we isolate our application with its dependencies, there's no problem, but then we need to have all of them identified. So let's recap a little bit. What do we have to do? We have to identify or to define all the things that can affect your ABI. For sure, the source code. We need at least, which is the name of the library, the version, what we call in Conan a user and a channel that we can associate in GitHub with the fork and the branch of the repository. Of course, we will keep also the commit hash and everything else. But with those 4 things, I think it's a nice first approach. Second one, we saw that the operating system can affect our binaries. So list all the operating systems we are targeting. Just, in my use case, I'm targeting to Windows, Linux, Android, iOS. I'm targeting to that versions. And I think that any change in those versions, I want to have a different binary. Tooling. As we saw, the compiler will generate different binaries. Just list all the compilers we are building our library. So the consumer can say, I want to buy you the library for CLang version 8 with those flags, because that's the one I'm going to use in my production environment. Also, there are some other settings that will affect our binary, like the build type, if it's in debug mode, release, or other definition, like the version of the CPP standard we are going to use, which some of them has ABI changes. And also, our library can have different options, and depending on those options, our library is going to generate different binaries. So list them with the possible options, with the possible values they can have. Given all of this, we almost have a combinatorial explosion, okay, because potentially each combination of each of the values can generate a different binary. Okay, some of them are not logic, but potentially there are a lot of them. Can tell you that we at Conan, for clib, which has no dependencies, we are going to talk about dependencies now, we are generating just 200 of different binaries, and we are not targeting all the compiler versions and so on. And those are 200. Because if you take into account the graph of dependencies, then you do have a combinatorial explosion. Because potentially, your binary will be different. So you can have a different binary for each combination of each of your requirements. And then, for sure, you have a lot of them. Many of them are going to be compatible, okay? In Conan, you can say that if you choose between all these versions of a compiler are compatible, so do not generate new binaries and so on. But potentially, there are thousands of them. And okay, no problem. Just, if I have the sources, I have my machinery, I generate my binaries, I graph all the meta information, the settings, the options, everything we have been looking before, and I can generate a unique ID for that combination and store it all in a database. It's not a big problem. You just have to do it, but it's nothing. There is no magic here. And then when someone asks, OK, I want a binary for this operating system, this compiler, the one who wants the binary can be a customer or can be a developer in our company that, OK, he don't want to compile the binary from sources, he just want to download it. We can choose the right one and deploy it to the production environment or to the workspace of our user. So what's next? Just put your developers to work, ask them, assign some workforce, assign some budget, assign some time, and start working. And at some moment in time, when you have spent a lot of money in your build system for your in-house problem, and someone arrives and tells you, OK, there is people working on it. You can use something that is already working for other big companies and that can work for you too. And yes, this is the pair you can get with Artifactory and Conan. If you think as Artifactory as the binary database, then Conan is just like an SQL Manager related to Artifactory. Conan can generate from those settings the unique ID he will use to retrieve or to update the appropriate row in the Artifactory database. OK, this is just one of the simplest functionalities of Conan, right? Conan, for each library, you need to write this is Python. I think it's so easy, we can understand it. Of course, we are from a more higher tier in the development chain. So with Conan, you can see there on the left that we can generate, so Conan can generate different IDs depending on the settings and the things we are giving to it. So we have a default configuration. It will be written in a profile, so it's not something that can change. And if we change some of the settings, in the second line, we are assigning the build type debug value. We generate a different ID. And third use case, we are introducing another setting with the operating system Windows. We generate a different ID. And this is one of the key functionalities of Conan. Okay, it's just an easy one, but it's to show you how you can achieve it. And then the Conan recipes will also need, in case you want to use Conan to retrieve your sources and to build your libraries, can also contain the definition of these functions with the instructions to compile, to build, and also to know which files should you package in your binaries. And the other way around, of course, you can use Conan to search a reference, to search for an ID, and know which one the settings and options you use in that moment to generate that binary. But this is about ABI compatibility. I have to talk here a little bit about Conan, but there are many more functionalities, and I think it's a cool product. If you don't know it, I think that and you do feel the binary compatibility issues, or you are targeting different platforms in your company, and then I encourage you to try Conan and to tell us what you think, and please give us feedback. I will be around the conference, and later in the discussion zone you can talk to me. We are going to be this year in all these conferences, so you can talk with the Conan team there. And always you can find us in GitHub, Slack, or Twitter. And also, I'm sure many of you have contact with someone of the community, which is an amazing community. They are doing a huge work. They are helping a lot to us. And without that community, we cannot do what we are trying to do. And just as a conclusion, I think that then, having all of this in mind, ABI compatibility is not a major problem. It's just that you have to use the right tool for the job. Of course, it's Conan. So thank you very much. Thank you for coming. You are welcome. And I think we have time for some questions.
Hello, thank you for your talk.
Hello, thanks.
Can you say about more closer integration Simic with Conan? I mean, what you can say about call Conan from Simic and workaround for this?
We already have that kind of integration. There is a tool we call Conan Simic, so you can Conan from inside Simic. And it will pass Conan the configuration you have defined through Simic. But I think it should work the other way around. The package manager is before you use your build system. Because calling Conan from Simic, and it's a little bit weird. You are going out to the operating system, generated files, then you are including them from Simic. So the idea is that with Conan, you tell, OK, I want to consume this library, and please, Conan, generate for me a file for my build system. You tell, hey, Conan, install this library, use the generator for Simic. And then we will generate the typical find package file, or the config one, or even a plain file which contains the folders and the flags. And you, from your Simic, include that file or maybe use it as a tool chain and just keep using the same CMake list file you were using before.
Thank you, but I mean that I need to know Python and Simic and maybe some more. It's difficult, and we want to new only Simic. It's better than more than one language in our build system.
But I think that Conan recipes, okay, they are written in, okay, you can write them in a plain text file, but as soon as you have to deal with a couple of things, you will move to Python. And I think that Python is very easy if you are doing just easy things. In a recipe, you will find just, okay, if the operating system is Windows, then call the Visual Studio solution you already have in your library. If not, use the make. So, yeah, I know that maybe you can even think why is it not in C++? Okay, we think it's easier and we can develop faster in Python. But yes, you will touch Python, you will have your hands dirty with Python if you want to use Conan at all his power.
Hello, thank you for your talk.
Hello, thanks.
As I understand, Conan allows you to manage libraries needed for the binary at the moment of building. Are there any instrumentary or tools in Conan itself to actually deploy the acquired binaries, like to install someplace and then you use it with LD library paths, or maybe integrate it in run path in binary itself or stuff like that? Like, what would you advise for the use case when you need to put all those libraries somewhere at the endpoint to run them?
There is a deploy method in each recipe and also an import one. So from a package, you can grab binaries from your requirements, and also in the deploy stage, you can copy those binaries elsewhere. Also, we have what we call generators that you can write your own, and that's Python code. So you can do whatever you want. So you have the paths to the binaries, the paths to all the packages, you know where it is each file, so you can write your own code to copy those files wherever you want, or to execute your scripts, or I don't know, whatever you are thinking about, you can probably do it from Python or calling the command line and using some tool.
You talked about std string ABI issue, and GCC libstd C++ resolved providing a dual ABI. Do you have a feature to generate libraries in a similar way, which provide dual or multiple ABI for different configurations?
But in order to provide multiple ABIs for different configuration, it's a matter of the language. You can do it with the inline namespaces. That is how it was done for the C++ runtime. I think it has nothing to do with the package manager. So I think it's more related to your sources and your code and how you write it. Don't you think so?
And another question, are there tools to check if a library is sensible to a certain option?
You can always, here in the, I'm sharing some links here. And okay, if not directly in one of these links, you can check this reference, and for sure you are going to find some tools that allow you to check if your ABI has changed. One thing people do many times is just a git diff of all the header files, just to check what has changed from one tag of your repository to another tag. So there are tools, yes.
У нас 3 минутки. Давайте 2 быстрых последних вопроса, а потом дискуссионную зону.
I have a long story, but well,
maybe we can discuss it in the afterward.
What is the retention policy for keeping binary packages in your repository? Because I have a bad story about homebrew bin tray, and please say me what you keep every released binary.
You know, we have a central repository, but it's intended to be for the open source and the community. Then Conan is distributed like Git. So you can use your in-house solution to store the binaries. You can use your Artifactory. You can use Conan server, which is free. Also, you have a free version of Artifactory for C++. And the policy you follow, if you are going to keep forever all your binaries or not, I think we are not going to enforce any behavior. So we just give you the ability to identify all of them. Because additionally to the settings, options, and so on, and that combinatorial explosion, we also associate to each binary the hash of the Python code that generated it. So you can, if you change just a comment in your recipe, potentially you will get a different binary, and we are going to associate that information. So from our side, we are not going to overwrite a binary you have in your database. That's not the idea of Conan. We think that it's something you have to deal with in your infrastructure. But I would want to know about your long history afterward. Okay.
Hello, and thanks for the talk. Please clarify. As far as I understand, Conan can provide pre-built libraries with needed parameters and ABI, but can it be integrated with built agents to build the library graph on demand?
Yes. So in Conan, you can use your requirements. You can retrieve sources and then compile them, or you can retrieve the binary itself if it is available, of course. So I think was that the question, or? Okay, thanks.
Thank you very much. That was a great talk.
Thanks. Thank you for coming.